Hey guys, this video is all about Simpsons Diversity Index and measuring biodiversity. So this covers the fact that when we think about communities, we want to have a diverse community because they are less susceptible to disturbance. Okay, so if you have a diversity with all oak trees and a forest fire comes through, the individuals that are left might not necessarily be the best individuals because they're all oak trees and you just don't know what's going in there. Okay? So bouncing back from that oak tree forest fire might be a little tough for that very low diverse community. However, if I have a forest that has a lot of different trees, got oak, got spruce, got maple, all sorts of things, got some dogwoods in there, and that forest fire comes in, it's more likely that that diverse community of trees is going to bounce back a lot quicker. Right? Also, having a lot of biodiversity has an aesthetic value. Let's think about the fall. You have fields of cotton that are ready to be picked. And you know what? That is Instagram worthy. Also, fields of sunflowers. That is Instagram worthy. But we put the cotton with the sunflowers, that's going to be blowing up the internet. Okay? Or I guess social media. So we also want to think about a more diverse community has more raw material to deal with. So you got a lot more genetics and you're more likely to get a really phenomenal organism if you have a lot of raw material to deal with. So looking at Simpsons Diversity Index, let's scroll. Here in our example, we have 4 different sites. We have our number of species, which is the richness. Obviously, if we look at just species richness, site A is going to win. It's got 10 different species. Site B has 5, and we have 5 in C and 1 in D. So D is low, A is high. Now let's look at our evenness, our distribution. Out of all 10 species, Site A has 1 of each. Site B has 2 of each. So technically A and B are exactly the same in terms of evenness. C is skewed towards one of the species, and then D obviously only has one type of species. So then we have to say, well then, okay, between A and B, which one is better? Well, this is how we're going to figure it out, through the diversity index. And we calculate it through here, where little n is the number of individuals for each species, and big N is the total number of organisms in the entire thing. Let's scroll all the way down to the back page. Alright, so here we see we are looking at species of trees. I have my number of each species, 2 wood rush, 8 holly, 1 bramble, 1 Yorkshire frog, and 3 sedges. So now that I have my little n, the number of each individual species, let's do some math. N multiplied by n minus 1. So 2 multiplied by 2 minus 1 equals 2. 8 times 7, 56. 1 times 0, 0. 1 times 0, 0. And then 3 times 2, 6. Now I got to find my 2 numbers. Let's find my total number of organisms. Remember, little n is the individuals of a species. So 2 wood rush. My big N is my total number in all. So 2 plus 8 is 10, plus 1, 11, plus 1 is 12, plus 3 is 15. And remember, you are allowed to use a 4-function calculator with these. 2 plus 56 is 58. 58 plus 6 is 64. Now I come down here, and I realize I'm missing the 1 here. That's okay. My top number up here Well, this is going to be my 64. My bottom number down here is going to be my 15. Now remember, this 15 is just the big letter N. So I must do 15 minus 1. So now I have 64 as my top number, and I need to multiply 15 times 14, which is going to be 210. 64 divided by 210 is 0.30, and I'm just going to round it to the second decimal place. But remember, my 0.30 is my Simpsons index, and I'm trying to find my diversity index, which is just 1 minus 0.3. That turns out that it is 0.7 for my diversity index. The closer we get to 1, 1 is amazing diversity. 0 is not diverse at all. So that means that this community of trees is above average. Not too bad, okay, but a little bit above average. Now go ahead and do the rest of this sheet.